Now we can finally add our first migration, and we'll be doing that using the command add-migration. Add migration will look at the DB context and determine the data model. Using that knowledge, it'll create a new migration file with the information needed to create or migrate the database to match the model. Let's use get help again so we can learn more about add migration. This little bit of documentation shows you the syntax of the add migration command with all of the possible parameters you could use, such as specifying the output directory. In fact, do you see this startup project parameter? That's the one that's the workaround if you don't have the startup project specified in Visual Studio. You can just specify it right in the command. Notice that at the bottom of this help, there's a remarks section, and that tells you how to get even more detailed information about the add migration command. Although add migration does have a number of parameters, I'm only going to use the required parameter, which is the name of the file you want to create. And the name is just a plain string. It doesn't need quotes. You could put dashes or periods in the name, or even spaces if you surrounded it by quotes. But the class that gets created in the migration file will strip all of that out, and that could lead to confusion as you're creating new migrations. So it's better just to keep it simple and use a name with no special characters. So I'll use the name initial since it's my very first migration. So add-migration initial. That's it. As it was creating the migration, EF Core saw that I had a decimal property, base price, in book, and that it's going to use its default precision and scale for the database column. And since this simple code doesn't have any constraints yet, it's possible that I might enter a base price that will get truncated when it gets put into the database. It's really good to read those messages. We're not going to do anything about it right now, but you will see later on in this course, when we look more at custom mappings, how to fix that particular problem. Let's take a look at what happened in response to the add migration command. Notice that there's a new migrations folder in the data project, and in there is the new migration file called initial, along with a timestamp. There's another file in there called pub context model snapshot, and that's where Entity Framework Migrations keeps track of the current state of the model. The snapshot file is really important because next time you add a migration, EF Core will start by reading the DB context to determine the current state of the data model. Then it will read the snapshot of the previous state of the data model and compare it to the new version of the model. And that's how it figures out what needs to be changed in the schema and is able to create a new set of migrations to get caught up. And it updates the snapshot. And the snapshot file is just a file. It's part of the project, and it can participate fully in source control when you're using EF Core and migrations across members of your team. If you're coming from pre-EF Core version of Entity Framework and you're on a team that's been using migrations, this is a really important improvement that we got with EF Core. The code in the migration file uses EF Core's migration API to describe what needs to happen in the database. So the first thing here is logic to create a new table called authors, along with the needed columns, ID, first name, and last name. And there's annotations here to describe the data types and nullability. But notice the annotation for the ID. It specifically says SQL Server Identity. That's because migrations did read the configuration information that we supplied in the pub context and knew that we're targeting SQL Server. And so it interacted with the SQL Server provider in order to determine some important metadata in this file. The way it was able to determine what these attributes should be is by using EF Core's defaults. We haven't told it to do anything other than to use its defaults, such as the table name matches the DB set name, and column names match the names of properties in the class. Even these data types are determined by convention. EF Core has a default mapping for every .NET type. And you can see it's also defining constraints for the authors table. And the only constraint here is that the ID column is the primary key. Then there's the books table and its columns. And look, even though I don't have an author ID property in the book class, EF Core knows that the database is going to need that in order to keep the relationship recognized in the raw data. The books table also has its constraints, and not just the primary key, but the foreign key connecting it to the authors table is described as well. I'll address this further on in the course when we get into relationships, but for now, it's good to know that EF Core recognized the one-to-many relationship that I created between my classes, and it inferred the relevant primary key and foreign key constraints when determining the tables that the classes map to in the database. It even specified an index. And EF Core's conventional rule behind indexes is to create an index for every one of the foreign keys that it discovers in the model. All of this logic is part of a method called up. And here's another method called down, and that's used if we ever want to unwind this particular migration. So that's it for the first migration, and the syntax is very similar to how migrations looked in Entity Framework 6, if that's what you're used to. With the migration in place, we now have everything we need in order to create a database. Not only do migrations give me the ability to have Entity Framework create the database for me directly, I can also have it generate a script, which is an important feature for working with a production database or sharing your development database changes with your team. The PowerShell command to update the database directly is update-database, and if you're using the CLI, that command is .NET EF database update. In response, EF Core will read the migration file and create the relevant SQL in memory. If the database doesn't exist yet, it will create the database using the connection string, and then it will apply that SQL to the database. If you're only creating a script, you'll use the script-migration PowerShell command or .NET EF migrations script in the CLI. In this case, EF Core will again read the migration and build the relevant SQL, but this time it puts the SQL into a file, and then it's done. With my development database, I'll typically let migrations go ahead and create and update the database for me on the fly. But with a production database, a more common scenario is to take advantage of the ability to generate the SQL and taking more control over how and when it's applied to the production database. While the update database workflow is much more common during development, I want to show you the script workflow first, so you can see what SQL EF Core is creating. Then, when I demonstrate Update Database, it may not seem so magical. EF Core's script migration command will build up the relevant SQL, in this case it's T-SQL because I'm using SQL Server, based on what it's discovered in the migration file. Since there's only one migration here, this is a simple script. When you have multiple migrations, there are particular behaviors to be aware of, and I'll show you that further on in the course. I've saved that generated SQL into a file called generated SQL that you can find in the download for this module if you want to look at it more closely. And now I'll show you how you can let EF Core migrations directly affect the database with the update database command. Before I run that, I do need to point out that I deleted the database which was created by ensure created in the previous module. So now the database does not exist at all, nor does any of the data that we've been working with. But I'm going to have migrations create a brand new database. I haven't changed the connection string, so the new database will still be called pub database. In fact, if we look back at the migration, there's nothing in there that says create the database. That's actually handled by the internal code inside of migrations, which first checks to see if the database exists or not before the migrations run. If it doesn't exist, then EF Core will first create that database at the given location. If you've created a script and you're running that, you will be responsible for creating the database yourself. I won't be using any of the update database parameters, although I will use a parameter that's common across PowerShell, which is the verbose parameter. This lets you see everything that the update database command is doing. In real time, this happened really quickly, so I've slowed it down so you can actually see some of the tasks it's performing. And you can see it's discovering the correct projects, it's rebuilding the solution, and then finding all of its assets. Finally, it applies the migration, and it's done. The whole process took less than 2 seconds. Now, after I refresh the SQL Server Object Explorer, You can see the new pub database and its authors and books tables. Those pluralized names were driven by the way I named the DB sets in my DB context. So what about that history table? Its job is to keep track of which migrations have been run on the database, and its columns are migration ID and the product version that was used. I want to look at the tables from a different perspective. I can't do this from Visual Studio, so I'm using Microsoft's IDE for SQL Server called SQL Server Management Studio. I just happen to have it installed already on my computer, so I'm taking advantage of it. You can see that it created primary keys. You can also see that the default data type derived from my string properties is an nvarchar max. Everything here is as it was described by the migration file. So in the background, it did create the same SQL that we got when we scripted the database and then just executed it on the database for us. If you're coming from an entity framework background, none of this is any different from what you're used to with EF6 or earlier versions. We saw in the migration code that it was working out not just the primary keys, but also foreign keys. And you can see those relationships that it was able to determine just from reading the classes are also visualized here in the diagram, along with the names that EF course conventions provided for those constraints.